is from point B, right? So now it becomes what? 2I plus by 3J. So for this, reference is at point where? Point B. Make sense or don't make sense? Okay, where the reference point is. Okay. So now in terms of displacement, okay, in terms of displacement, what we have is going to be equal to dRB is equal to dRA plus by dRB over A. Okay. So why does it look like this? Okay. So the next figure that I'm going to use is this figure over here. Again, these figures are available on Avenue to Learn. Hey? Oh, crap. Seriously? I told you guys, right? Juggling 10 balls up in the air at the same time and always dropping them every second. Like you guys, okay? It's normal. So I did not post it yet. Oh, such a blur. You're right. Oh, so sorry, so sorry. See, yeah. 1,000 apologies. Can you see it again, please? Do apologize, okay? Yep. Okay, you get a pint from me. 2 pints. Okay, it's embarrassing now. I don't know where to hide my head. So what you see over here, right? When B, right? So this is, I want you to focus, this is at time, right? And this is time plus by d theta. Okay, so this is now. And then what you see over here is later. Okay. So RB down here, the first term you see it down here. Okay. Now this is due to translation and rotation. Okay. So when you see your first DRA over here, okay, over here, this is due to translation. And the second term over here, right, this is due to rotation about point A. Okay. So you can see what is going on initially, right? From A, okay, so from I'm going to highlight, okay? From this beam onwards, if it's just translation, it just come over here, right? But that's not the true motion. The true motion also has a what? Has a rotation, right? And when it finish rotating about A, right, it end up down here in this position. Okay, so you can refer to the figure. And the final equation in terms of velocity is not that bad. Okay, as I said, this chapter is not that bad. It is dependent on how crazy the prof want to be. Okay, and finally, in terms of velocity, we have the expression where we use drB over dt, and this is equal to dra over dt plus by dr point B reference point A divided by dt. So this entire equation over here, okay, it will be expressed as velocity of point B is equal to velocity of point A plus by velocity of point B over A. So a rule of thumb to remember this is whatever is on your left-hand side, your B, is going to be the point of interest. And over here, this is your what? Reference point of interest. Okay, that is always your point of interest. Okay, so let me define. So VB is going to be the velocity at point B. VA is the velocity at point A, and point A is known as your reference point. All of a sudden cannot spell reference. And lastly, VBA. So this is the velocity of B with respect to point A. Okay. So the last term over here, VB over A. Oh, I did VB over A already. Okay. So this expression over here, VB equal VA, VB over A. All right. We know there's a rotation. This is basically a rotation. Okay. So we know finally the form is equal to VB plus by VA, not plus, equal to VA plus by omega cross RB over A. Okay. So omega is the angular velocity of the rigid body. Okay. Okay. So I'm going to briefly write about the solution procedure. Yeah, I'm going to write down the solution procedure. So just follow this procedure and you will be fine. Okay. So solution procedure. It's not difficult at all. You have to determine the X and Y coordinates. Okay. Now the X and Y coordinate is not necessary. X has to be vertical, Y has to be horizontal. I repeat again, not necessary. That X has to be horizontal, Y is vertical. What do I mean by that? Okay, so whenever I teach, I have to do examples. So let's don't worry about this. Okay, I want you to look at on this example now. Okay, just briefly. Okay, we're not going to solve it yet. Okay, I'm not that bad. Okay. Now, mathematically, so what we want to identify, what this question want to find, is we want to find what is the angular velocity of gear B. Okay. Or sorry, what is the velocity of gear C? Right. To make things simple, right, we make our X and Y coordinate in this direction. So this is our Y. So this will be our X and this is our Y, because over here, Y that direction, this is the what? Point of rigid body of interest. Okay, it will save you a lot of mathematical calculation. Are we clear? Okay, so why that direction? You only need to deal with what? You only need to deal in velocity in the x direction, and the location is just in what? Y direction. Are we clear? So this will simplify your calculation a lot. Okay, so the next thing after that, we have to then determine or find VA and what? VB, omega, and RB relative to point A. Okay, so from here, we are going to use velocity equation. To determine, use velocity equation. So velocity equation is VB is equal to VA plus by omega cross VA or VB relative to point A. So if or when the solution is negative in magnitude, so let's say you get a negative number, it indicates now magnitude, yeah, magnitude, yeah, it indicates that the direction is opposite. Okay, straightforward. Yes.
Isn't it like RBA, not V? Like across R, V relative.
Yeah, it's RB over A. A is your reference point.
It's like the velocity equation.
So VB is equal to VA plus by omega cross VB over A.
Oh, it's like V, not R.
Oh, yeah. Oh, you caught me. 1 pint. Okay, thank you. Okay. Okay. So to end, if we were to look in this diagram, okay, you can see that this is the rod that we want to determine the velocity at point B. So what we do first, okay, we force, okay. So at this stage over here, what we do over here, I'm highlighting yellow. We let point A and point B to be moving in a translation direction in VA. Then after that, then we incorporate the what? We incorporate the omega RBA to determine what is our velocity at point B. Okay. Before I stop, I will like you all to pay attention to just quickly, okay? Pay attention to this. Pay attention to what? I want you all to get used to planetary gear system. Okay. Right. So what we have here is a planetary gear. Okay. Before we talk about planetary gears in our solar system, what do we have in the center that is the biggest? We have the what? The sun. Yes or no? And then circulating the sun, we have the what? Planet. Right? So is the sun, okay, from our point of view, is the sun moving? Is the center of the sun moving? From our point of view, it is not. What is moving is what? Planet Earth, yes or no? So i.e., the center gear is always known as the what? The sun. The gears that are rotating are known as the what? Planet. And the outer system is known as the what? Ring. Always remember, okay? Always remember this. In a planetary gear, one of the gears cannot be moving. I repeat again, right? Always remember in planetary gears, one of the gear is stationary. So for example, the ring has to be stationary, or the sun has to be stationary, or the planet has to be stationary. One of it has to be what? Stationary. Are we clear? Okay. If that's the case, happy Thanksgiving. And I'll see you guys when you all come back strong and almighty. Okay. Grades will be out on Saturday morning. Okay.